And where do I stand there? I guess so, right? You'll adjust the camera. Let me just get this.
I'm just going out and unmute yourself. And
okay. Shall I unmute myself? This is an audio test for the live stream. This is an audio test for the live stream. This is an audio test for the live stream.
What do you do?
This is an audio test for the live stream. This is an audio test for the live stream.
switch it off, so it's not.
Yeah, just yank this out. We don't need this. Just pull the wire out.
I just opened Facebook.
No, while you're monitoring Facebook, you keep it on mute. Otherwise, that will be feedback. Yeah, always.
Okay. Who's going to monitor Facebook and YouTube comments?
You can do one.
You can do Facebook. Okay, you can do YouTube. I can log into YouTube on that one. I'll just keep the YouTube one on that one.
It's need at the end only, right?
No, I'll just in the beginning itself I'll tell them Eclipse meeting is good. Actually, I should even. That is our YouTube. That is अन्य लगा. Should I just keep the Unlay video on rather than the boring?
Yeah.
Like 5 minutes.
Yeah, 56 more minutes. Okay, where is the list of experiments? Let's tape it so we don't miss it. So I'm going to do first talk about pulleys and changing force. The first experiment we are doing is with the sticks. Okay, that the pulley, I'll show the pulley changes force. Sticks, it gets very hard. If you multiple pulleys, then we'll throw the thing over the weights over the pole. Hello. Hello. Hi. Okay, fine. All right, cool. eat something. I'm going to eat during the eclipse. Okay, chalo. Yeah, bye. Where is the? In Mumbai, it will be at
11:35 something.
11:37, I think, is Mumbai match coverage. Yeah, somewhere around that. Yeah. Okay. Yeah. So at 11:37, if you want, you can go out and take some photographs.
Mm-hmm.
I'll manage it. Where is our YouTube link? Okay, we are still showing this.
Yeah, you have to change the share screen here from it.
Yeah, I'm still. Oh, yeah, if I want to show this, maybe I just start the session and then switch.
Yeah.
So, but can you then can you somebody sit here after I introduce? Okay, can you turn this on me now? Just get this on me. This is terrible.
No, I think let it focus.
Get this
Yeah, the light off. Yeah.
Off. Yeah. And let's get this up. You might have to hold it.
Yeah.
Okay, and then you stop sharing and switch the get rid of the white area. Yeah.
Like that.
Okay, is this good?
Yeah, okay.
Yeah. Fine.
Hmm.
Okay.
But
Stop sharing. It's 11 o'clock. Stop sharing. Okay. Unmute and let's go live. We are live.
wait.
Hey, careful. Just unmute me here.
But I have to
That's
change.
it. And unmute and stop share. Click on stop share. Excellent. Okay. And go to just click on. No. Just go to my video. Double click the video. Yeah, that's good. Okay. Okay, it's 11 o'clock and time to begin with a rather exciting chai and wai on the the summer solstice day, where we not only have a chai and wai happening here, there's an annular solar eclipse happening crossing North India today. In fact, were it not for the COVID lockdown, many of us would have actually been somewhere in North India trying to chase the eclipse and probably would have been doing a chai and wai on the annular solar eclipse from there. But given that we are stuck here in TIFR, we'll try and do our best, try and bring you glimpses of the eclipse as well. Please note that if you'd like to follow the eclipse along, there are lots of live webcasts of the eclipse as well. There is the Indian Institute of Astrophysics at Hanle. They are having a live webcast. Vigyan Prasar is live webcasting from Kurukshetra. Ayuka has an entire panel of experts in Pune, and they are showing live feeds from various cameras across the country. So there's a lot happening, and we'll also try and make sure that you do not miss the live, at least the annularity part of the eclipse. So we can quickly check what the eclipse is like doing. Can you just check if you can share to the, can we show them the, yeah, just share screen. Click share. Yeah, so that's what the eclipse is looking like right now. And you know, the first thing you should do when there's an eclipse is you should make sure that you eat something. So if there's an eclipse, the most important thing to do is never believe in superstitions. It's always safe to eat during the eclipse. And you know, the Astronomical Society of India has the eclipse eating thing. So I'm going to start this off by eating a biscuit, just to say that it is perfectly safe to eat during an eclipse. So, do join me wherever you're watching. eat something during eclipse eating is perfectly fine. Okay. Stop the share. We will check back on the eclipse periodically. Today's session is supposed to be about a bit of string. Now, string comes in various kinds. You obviously have thread that's used for stitching, simple roll of thread like this. It could be a spool of wool like this. You have nylon ropes that you use to hang clothes or tie up things. They come in, you can have thin rope, you can get thick rope, and you also have rope made from natural fibers like jute. So there are lots and lots of fibers that are used for making thread, strings, rope. What's the difference? Well, actually, mostly terminology. So it all starts off with natural fibers, plants like cotton, they give us fiber. People have, since prehistoric times, figured out that you could use some of the natural fibers, like beans, you can strip off beans and you get little threads coming from them. And twist them together, or cotton, twist the fibers together and make something which is useful. It's useful for tying, it's useful for pulling, it's useful for lifting, and the most important thing, people figured out that you could take many of these fibers and weave them to make cloth. And cloth is something that we use all the time. If you have a very long length of fiber, it's typically called yarn. And yarn these days is both spun from natural fibers, but you can also get filament yarn, which is one natural example of filament yarn is of course silk. Silk is a long filament, but many artificial fibers are also filaments. And to make it stronger, you can then take many of these thin things and twist it together and make rope and things like this. But okay, I shouldn't be talking, I should be doing some experiments. Okay, so let's start off doing some experiments. We'll try and show you some of the experiments on the webcam. But before that, maybe you should see what we have on the table. Can you just show them? So what we have is, it will be definitely nice if you can get some thin thread like this, with which you can do experiments. Some little, even that thread will work, or slightly thicker thread. Some rope would be actually very nice, either jute rope or nylon rope, whatever you have. And you would need two little weights. I have a light weight, which is a spoon, a heavy weight, which is a spoon, and a light weight, which is just a pencil sharpener. So this would be good. If you can get something on which you can, if you have a spool of thread, very good. If not, just find something, a tube around which you can wrap some thread. Can make some nice, interesting observations with it. A straw would be very nice if you'd like to make a toy. Okay, and a button as well. Where's my, yeah, okay. And also do try and see if you can get a little button, a button through which we can thread some thread. Okay, let's see. So the first experiment we do is, well, strings are usually used for pulling, lifting, etc. The first one we will do is a rather let's start off with something which is not so easy to think of. Okay, so here what I have is a spoon. I have a spoon. Here's a spoon. Okay, and what I'm going to do is I'm going to take a little bit of, we'll just make one more of these, so we'll start from scratch. So I have something that is light, for example the spoon, this is heavy, a spoon, and something light like a sharpener. So you can find anything at home. Maybe you'll find an eraser, maybe you will find, it doesn't have to be a spoon, it could be anything. You just do it with stuff available at home. Find something that's relatively heavy, something that's relatively light. So here is a spoon and a sharpener. Okay, what I'm going to do is take about, how much string do we take? We will take about this much string should be fine. Okay, just about something which is, yeah, little more than, let's say 2 feet of string, 2 feet, somewhere between you can actually experiment and practice with how much string works best. So you take this string and okay, so here's another piece of string I have. It's already cut, but can you cut this for me? Okay, and all you do, we're going to tie one end to this spoon. So here we go. We tie one end to the spoon, and the other end, can you just tie the other end to the sharpener? So let's hope you're following with us at home. We tie it. Okay. All right. So now I have a piece of string. On one end there's a spoon, on one end there's a sharpener. And here is a little setup I have. There is this little bar on which I can loop this guy around. So the spoon is hanging. You see it's hanging spoon. Now the spoon is obviously much heavier than this sharpener. And if I let go, what do you think is going to happen? If I let the string go, what would happen? The string is heavier, it's going to go down, and well, you might think it'll fall, and you would be right. If you drop it, the spoon should fall. Now, you need to find some place to do this, and if you obviously, the easiest thing to do is to find somebody to help you and find a stick or a pen or something. I mean, you don't have to do this with a thing like this. You could just catch a pen. Have somebody catch a pen and do it, hang it on a pen. Okay? So let's try this. Here we go. I don't know if it's going to work. Okay. So here we are with a spoon.
Put your finger.
Okay, I'm just going to keep it. Okay, somebody press this down so that it doesn't slide off. Just keep your finger on this. Okay, great. So we have this horizontal, we have this here, and I am going to leave the spoon, and let's see what happens. Well, it didn't fall down. Can you see the spoon is hanging here? Can you just tilt the camera down a bit? Yeah, the spoon is still hanging here. Never believe an experiment done once, so we must repeat this. Let's repeat this. Okay, here we go. Here's a spoon, much heavier than this little sharpener. But watch how what the sharpener does when I leave it. And it got locked over there. Isn't this? Did you think this would happen? Did you think? Now, what is that going on? Let's suppose I leave it like this. If I leave it just like this, then most likely it will fall down. But if you leave it at a slight angle, that's what I'm doing. I'm tilting this a little bit. Okay, maybe you should. Can you show that the thing is? I'm leaving it at an angle. Very tough to see this. I can do it. So if you see, I'm holding this at an angle, not absolutely vertical. I'm holding this at an angle because as it goes down, I want this to loop around the rod. Okay, that's what we're trying to do. So we do this the third time. Here's a spoon. I drop it, and there you go. It works. Isn't this non-intuitive? You didn't think this would happen. So the question is, of course, we are not doing any magic in science. We are doing things which depend on the laws of physics. So why does this happen? Well, this happens. You should try it out. Try it out. Give yourself some time to try this out. It happens because since I'm leaving this at an angle, this part, this sharpener actually goes and it loops around. It loops around this rod. If you're doing it, you can even do it with on your finger if you don't have anything else. I can probably do it on my finger. Let me try if I can do it on my finger. Can I try? No, my finger is too rough. But maybe we can have somebody hold a pen or something. Or yeah, anything is fine. So that's too low. Hold it higher. Let's see if we can do it on a pen. It's going to hit the table though. Yeah. Okay, here's on a pen. Okay, it's going to work as long as you have some support on which you can get your string to wrap around. So why does this happen? It happens because the rope, the string that you were using, loops around this rod or around the pencil or whatever you were using, and there's friction. Now friction, the stuff that opposes things which are in contact moving against each other, is so important. It is so important, and many of the things which involve the uses of rope, the fact that we use thread for stitching or whatever, a lot of things depend on the fact that the ropes are not going to slide because of friction. So friction is something really important. We're going to do some more cool experiments with friction on this, but meanwhile, let's do something fun. Okay, so we'll show you something which is, again, almost magic. Okay, this wasn't there in the list, but I had Divya Shankar, who found something really cool last night. He was playing around with a ring and some rope and whatever else. So he thought, hey, I have something cool I want to show you. So let's get Divya Shankar in and let's see what he's got to show. So come on, Divya, where's your little toy? Where's your? Do you want to do it here or against this background? What's good?
Is this open? Yeah.
Yeah, I think just come here. Just come here. Okay, now we don't have a zoom, so we will have to.
Okay, I will come.
You can come closer. You can come closer. Yeah, very nice. Very nice. Good. So Divya has actually got a. Yeah, that's fine. That's fine. That's very good. Good. Keep the lights like that. Okay. So he's got a little ring. This is a ring which was from a chain which you used to chain your luggage, perhaps in a train or something. A little ring, and he's got a chain. This is a little metal chain, which is also like a thread or a rope, but you can do this with rope as well. It works much more easier with this, and this is going to be quite crazy. So let's just watch what he's going to do. So Divya, tell us what you're going to do.
Yeah.
If you remove your mask, people can lip read you, so it's really important. Yeah.
Okay.
So because lip reading is okay,
Okay.
and be loud.
So I initially start like this. So can you see that
Yeah.
I'm holding that ring on my 2 fingers, and the chain is actually passing through it.
So the chain is all just passing through it. Okay, the chain is just passing through it. Okay, here is the chain passing through it. Very good.
Okay.
Okay.
So now the thing is, I'm going to remove my fingers, and the laws of physics tells that it should fall down, right?
Yeah, you haven't switched off gravity, right?
No.
No,
I will
okay.
switch off gravity. The Newton's law actually prevails, so it will fall down. So let's try.
Uh-oh.
So let's try once again.
Well, he's got it knotted into that somehow or looped into that. Let's drop it and let's see if it falls.
No.
No, it didn't fall. Now that is weird. Well, you are doing something.
That's the magic, right?
The ring
Grab
is.
that.
Wait, there is no magic. Remember, we've said there is no magic. So let's see what he's doing. Let's
Okay.
observe
Now,
carefully.
if I want to remove my magical power, so you can, with your willpower, you can control the gravity, right? So whenever you want,
Well,
you can
gravity
switch
is there.
on
It's just
gravity.
getting locked or not locked.
Okay. So now, if I want to say that it will
can
be
you-
locked.
Can you drop it? No. Can you show them this way that it will fall down?
Okay. So now
It fell down. And now let's see how it gets locked.
so now I want it to be locked. Okay.
And it got locked. So observe carefully again. Unfortunately, we can't watch this in slow motion, but we will watch him again to see what happens. How does he drop it when he gets it locked and when it falls down? So let's do a falls down.
Yeah.
Watch the ring. Watch his fingers. Watch how he drops it. I'll hold it here so it will fall on my hand.
Oh, sorry.
Oh, that got locked. Oh. Okay, let's see if this one will fall. Okay, clumsy me couldn't pick it up, but yes, it fell down. And now let's see how it gets locked. And it gets locked. Okay, Divya, and I think people have been quite curious as to what's happening.
Okay.
So,
So if I want to explain this, so it could be better if I use a slow-mo camera and you can actually see how I am leaving this ring in the chain.
So the important thing is to watch how he releases the ring.
So the physics is if I remove two of my fingers simultaneously, so the laws of physics will govern and ring will fall like this. Okay, this is simple. What we expect, right? But the unexpected thing is if I remove one of my finger a little earlier than the other, so what will happen? So initially, if I say I remove my thumb earlier, so it will go like this, right? It will rotate. But if it complete one rotation, then also it will fall. Okay. So what's the magic, quote unquote magic in it? So that when it falls, it has to complete two complete rotations. Then it will be locked. So small change in initial condition, like when I'm removing two of my fingers simultaneously and with a small delay, can cause a huge rotation in the this relative motion between chain and the ring, and that will eventually cause, dramatically different result. So you can
Okay, let's do this now. Look at it and see if you can watch the ring when it's falling down. That went down straight, and now let's see when you release one finger slightly before the other. Watch the ring. Did you see it taking two turns?
Yeah.
Unfortunately, we don't have a slow motion camera on this.
You can try this at home. Yeah, you can. This ring is from a luggage
chain.
Chain.
But you can try a keychain ring. You can try any ring.
So in morning, I actually tried
and
with
you
this
can try with a thread as well.
So it happened. I can try once.
Let's try with a thread if we can do it with thread, since this was supposed to be string and thread. Yes, I can get it through. There it is. Okay, that is thread. Leave it. No. Let's try again.
So it happens.
Well, it's
sometimes
you need to have enough time for it to actually do two twists. Yeah. There you go.
So you can try with this kind of thread also.
Try with a chain. You can try with this. Just as a fun example, we sort of just discovered this while playing around last night. But that is okay. Do we do a quick check on the eclipse?
Yeah, so she's taking pictures.
Okay. No, do you want to just check on the? Okay, so that was you saw a little bit of a spoon going around, or rather the sharpener going around the pole. Yeah, let's just quickly check what the eclipse is doing. It looks like a nice crescent, just like the biscuit I had chewed on. Okay, so if you're watching in Mumbai, the maximum is only going to be about 70%. And that's at 11:37, so you have about 15 minutes for that. In most places in the north where it is annular, the annularity is at about 11:57, 12 o'clock, depends on the latitude where you are. So we will of course go towards the annularity. When it is annularity, we will switch to the webcam showing us that. Okay, so let's stop that and come back to our... So we were talking about friction, that it holds things together. Now friction is sometimes much sort of, non-intuitive. You can't really think, because we have a problem. It's just like the COVID growth rates and everything. Exponentials are not something our mind appreciates, because we don't see exponentials every day. But now that you definitely in the last 2 months, if there's one word you've heard of, it's exponential growth. Exponential growth. We even had a chai and Y on it. So friction in a rope can also show you some interesting exponential behavior. So let me try one experiment with this, and we're going to go back to this little rod of ours. And I'm going to again try, the spoon was not really heavy. I want to try hanging something heavy, and what I have with me is we figured we need to get weights that you can get at home. So hopefully you have a bottle of water. This is 1 kilo. If you don't have a bottle of water, it's fine. You can take something that's heavy. Take your, pressure cooker or something that people wouldn't mind if it falls on the floor, because experiments often don't work. So here's a bottle of water, and I have some rope. Okay. and I'm going to just put this rope around the bottle. So let me just get the rope around the bottle. Okay, here is a bottle that's hanging on this rope, and I want to hang this bottle from my favorite rod over here. I'm going to hang it, and how much weight do you think I need to put on the other side? I have 1 kilo on this side, and I want to put some weight on the other side. Of course, there is some friction over here. Right? There is some friction at the support. So what I'm going to do is I'm just going to wrap this rope around. I'm going to wrap this rope around 4 times, 5 times, okay? And how about I just leave it? So there's nothing on this side. Oops, I pushed it off. But here we go. I have 1 kilo bottle. I'm just going to take this rope and wrap it around this pole a few times. And the friction is such that it is actually sufficient to hold the weight of this bottle. Because, let me try and draw this up. Let's move this. Okay, I'll just draw this large so that you don't have to worry. Imagine this is your pole. Can't be seen. Can't be seen, can't be seen, can't be seen. Okay, we'll do that later. Doesn't matter. So it's okay. Just I can do it on the board.
Yeah.
I can do it on the board. Okay. So if this is your pole, and here's a rope that's going around it. Okay, this is the rope that's going around the pole. In this part, there is some part of the pole which is the rope which is touching the pole, which is this part. Okay, and please keep the light. Okay, this is also fine. So this part is the part where friction is important, and if you wrap this out many times, so it turns out that the force on this side, right, depends on this friction over here, and it actually depends. If you look at this length, it depends exponentially on how much the length is, and obviously if I wrap the string around a few times, the length is going to increase quite a bit, and since it increases exponentially, the force grows very quickly. So here you are, we can hang a 1 liter bottle with some rope on a pole. Let's see how many turns we need. 1, 2, 3, 4 turns. Let's try with just 4 turns. It is still slipping, it is still slipping. Right, a few more turns and it hangs. Now, where does this use? If you've ever seen how ships are actually moored, when a ship comes to the shore, what do? They don't really, there are all these ropes, they throw the rope to somebody on the shore, and there are these little pillars at the quay or wherever the ship is going to dock, and the person or the thing just takes that rope and ties it around this thing. And he doesn't really tie a knot or anything at all. All you do is you take that rope and you turn it many times around this little pillar that is there, and the friction is enough to hold the ship. And this is done obviously not with one mooring point, but with many ropes, typically a few ropes in front and a few ropes at the back. That way the ship is kept steady. So this whole idea of how ships are kept steady when they come to the pier is just due to friction on a rope around a pole if you turn it many times. Now, I don't have was this impressive? 1 kilo. I don't have a ship with me, but let me see if I can do something slightly better than this. Okay, let's try something slightly better. So, what do I have? Let's see, do we have anything heavier than 1 kilo? Let's search for something heavier than 1 kilo. Oh yeah, let's try. Wow, oh man, this is heavy. This is heavy. This is a jar of water which is 5 kilos?
5 kilos.
5 kilos. This is 5 kilos, 5 liters of water. Okay, let's see if we can hang this thing without nothing but friction. So first, I this rope through it. here is it. Okay, 5 kilos. And I hope this guy doesn't break. Okay, let me see. And oh no, wait, this is too big, it's gonna touch the side. I'll tell you what, I'm gonna start on this side and wrap the rope the other way around. Okay, so it is hanging here. Okay, let's just move it around once, twice, thrice. Of course, we are going to need more than the 4 turns we need for 1 kilo. But again, we're not going to need 4, 5, or 20 turns because remember, this is an exponential. I dropped something. Is that good? There we go. So remember, we needed 4 turns for 1 kilo. But just at about, there's probably 10 turns, I have 5 kilos. And this is because friction is going exponentially up. So, even if you can take a 100 kilo weight and hang it with just a few more turns like this. It is just amazing how sticky friction can be. Okay? So here is 5 kilos. We haven't put any weight on this. There's no weight hanging this, just the friction of the rope that's holding it together. Okay. In fact, I'm having him hold this on the other side. I'm unsure whether this weight will actually cause the retort stand out here to twist. Okay. How was this? Let's try and take this off. Let's see how many. Let's release this. See, it's still there. Let me just put. So, what have we seen? We've seen that friction plays an important role, and friction is actually what helps ropes and threads. And whenever you tie something, the reason a knot doesn't slip, of course, you have to interlock things. But the reason most of these things work is because when you get ropes in close contact, friction comes into play. Okay, so that was something interesting. Let's try and now look at some simple stuff. You want to roll your you want to wrap some thread around something and roll it? Or shall we make some toy? What shall we do? Let's make a simple toy. Okay, let's make a simple toy. We'll make one from scratch, so we'll take this off. So what we're going to do is we're going to make a toy which involves, I'll show you the final shape of the toy. You might have played with this, at least I have played with this when I was small. It's just a little button in a loop of thread. Okay, but we'll make this from scratch. So where's our thread? Our thread is here. Just cut this out. We'll do this from scratch. Okay. So here's a button. Okay, and I have thread. All what we're going to do is we're going to put this thread through the button. Okay, so we put it through one of them. Just what I'm not good at. There we go once. And I put it back through the other side, through the one opposite to it. Okay, has to be symmetric. So it's going this way, and I'm going to put it through this one. There we go. Okay. And I will keep enough length. And can you cut this so we can tie the ends up together? Just cut this off here. Okay. And all we do is tie a knot at the end. By the way, people actually use very funny terminology for what we call knots. If you tie a knot with the same string, it's a knot, obviously, if you tie a knot. On the other hand, what we were doing, where we were putting rope around a pole, that's, in the language of people who are very finicky, is called a hitch. If you tie a knot around a pole, it's called a hitch. And if you tie two different threads or different ropes together, that's called a bend. So, if you know anybody who's into sailing or shipping or something, they tend to be very finicky about their knots. They'll complain that, oh, that's not a knot, that's a hitch. Okay, so here is my little toy. All it is, it's a button looped through a little bit of thread. Okay, I'm going to keep the knot at one end, keep my finger through it, keep the button in the middle, pull on the other side. Where are we? Okay, so here it is. So this is my little toy. What's so great about it? So this, of course, you can make it spin. How do you make it spin? You put twist in it. So easiest way to twist it is to just turn this guy around many times like this. So I'm twisting it, and now if I just pull this, well, the twist will unwind and the button will spin, but it stopped spinning. The fun is to actually try twisting it in a way that the button spins and then wraps it the other way around and keeps spinning back and forth. And that is something which you need to play with. And at least if you're my generation, you did a lot of this when you were small in school. There were no mobile phones and video games, and we had to deal with simple toys like this. So you can spin this, hold it, and it'll spin back. Now, one easy way to do it, I'll tell you the little cheat, is after you spin it, here we are spinning it, this is twisting it, and it spins. Now, depending on whether you hold this tight or not hold this tight, it's going to spin the other way around. And you can make this spins, spins, spins. You can do it a few times. So you keep practicing with this, and you'll figure out that in some ways you can actually make this spin rather fast. And you can put a lot more twist than what I'm doing. You see? Okay, so here's a very simple toy. Now, what's the physics in this? What is the science in this? Okay, this was so simple. All it had was, it had a little button. It had a little button on a string. Now, this is an example of energy conservation. What were we doing? We were doing an experiment in energy conservation. When I turn it this way and I twist the string, there is energy being stored somehow. You can call it potential energy in this twisted string. Energy is being stored in this twisted string. When I stretch it out, that potential energy is going into moving this button, the kinetic energy of this button. And this button behaves like something called a flywheel. It's storing energy. In many times when we want to store energy, especially energy of rotation, the easiest thing to do is to use something heavy which can rotate, because that would keep rotating for a while. It's called a flywheel. And here is a little example of a button on a string, which you can make a little toy and see the transfer of energy between potential and kinetic energy, because once it twists, it sort of overshoots and makes the string twist the other way around, and you can keep playing with this. And you'll get some nice patterns on the string also if you observe carefully. You'll get some very nice, beautiful patterns. Okay, time to check the eclipse. This is about the maximum eclipse time in Mumbai. If you're in Mumbai, it's a good idea to go out and see the eclipse right now. Take a look out of the window. Of course, I mean, the easiest way is to get a shadow of the thing. If you look through shadows of leaves, for example, or shadows of trees, you will see that the trees cast crescent shadows. You'll have to do this with this one. Let's just see if any of the other cameras are.
This one.
Yeah.
Should I share screen?
Share screen.
This?
Go there and just click play again, because it's not live.
Oh, okay.
Share. And
Oh,
just
okay.
go to play. Or reload or something. Yeah, so this is at Hanle in Ladakh, but this is probably what you'll see in Mumbai right now as well. Let me just see if I can get one of the Mumbai cameras on to show you the eclipse. Also, I should tell you why we have an annular eclipse. Oh wait, how do we do this? Let me just check if the other cameras are on. Kurukshetra. Yes, Nehru Planetarium should also have a feed from Mumbai. No, this is not working. Okay, that's the Nehru Planetarium in Delhi, I think. That's doing it.
Oh,
So there are many planetariums in Delhi. But let me actually tell you what is this annular eclipse about. So can you just turn the camera here?
I'll stop share. Should I stop
Yeah,
share?
you can stop. So we are really fortunate. We live on a planet with a moon which is just of the right size and at the right distance that it looks the angular size in the sky. The size in the sky is the same as our star, the sun. And the paths are such that once in a while the moon can come in between the sun and the earth and just exactly cover the sun. Of course, there is a slight angle between the two orbits, which is why it doesn't happen every month at every new moon. That would be fantastic, but it doesn't happen. It happens rather infrequently, and if you're in one place on earth, it happens very infrequently at the same place. So, if you're lucky, remember the size of the moon is just about the size of the sun, the angular size, the apparent size in the sky. But that depends on how close or far the moon is. If the moon is rather nearer, then its size is slightly larger than the sun, so you'll have a little longer eclipse. It will cover the whole sun. You can see a total solar eclipse, you'll see the solar corona and all these things which you can't see otherwise. Now, if the moon is slightly nearer and it is just a tad smaller than the sun, it will not cover the sun's disk entirely. It will probably cover 97% or 98% of the sun's disk, leaving you with a little ring, a little bright ring of fire, which is an annular solar eclipse, which is what is going to happen today, or is happening right now. And today's annular eclipse is actually very close to total. It's almost 98 point something percent. So most of the sun gets covered, leaving a very thin ring. And you can sometimes see very interesting effects just when the moon is covering, because the moon's edge, there are mountains and valleys through which the light can pass, gives you very nice, interesting phenomena called Bailey's beads at the edges, just at the moment where it touches the disk of the sun. So we will try and bring that to you in a little bit. And by the way, if you want to learn a new word for the day, I'm sure if you're in school and you've studied, shadows, and they've told you about an umbra where it's a total shadow, and a penumbra where there's a partial shadow. For the annular solar eclipse, there's yet another word which you can learn, new word for the day. The region behind this umbral region, which is still not completely lit, there's this little ring. It's called an antumbra. If there's a new word you'd like to learn, it's antumbra. Look at it, doesn't matter. Let's go on. Did you go out and see the eclipse? About 70%? Okay, some of the people are going out. Good. Hope you could see it. We will switch to the eclipse camera in a little bit from Kurukshetra or some place where it is total. Annular. But by the time, let's do another simple experiment. And to do this, I'd like to invite Prerona. Prerona has been trying to wrap some string around a rod, and let's see what she's been doing with that. So, yeah, that one we'll do. Oh, okay, we'll do this one. Okay.
Whichever.
Let's do this one first.
Okay.
Yeah, we'll do a simple one first. Make some space on the table. Okay, so what we're going to do is, here is Prerna. Prerna, what do you have with you? Why don't you show people first what you have with you? So she's taken a little,
This is just an sewing.
it's a sewing thread,
yeah.
which is wrapped around, wrapped
Yeah,
around,
the normal thing that it's.
okay,
used
it's
to
wrapped
do.
around just a spool of sewing
Yeah,
thread.
yeah.
And just to make it easier to roll, she's put two little discs at the end.
Yeah.
Okay, but even if you do it with the spool, it should work.
Yeah, this is
But just make sure that a spool of thread like this is often wrapped from bottom to top and bottom to top.
Yeah.
This is meant for a machine. This has to be wrapped in the same position. You have to wrap it. So
Yeah, so
remove
I've
it,
taken out some
take
part
out
of
the
it
thread and wrap it at the
wrap-
same position. Okay, so get a spool of thread where it's wrapped around at the same position. And now shall we do it on the table?
Yeah.
You want to do it on your book or on?
Let's see if it works.
Let's see if it works on this. Okay, so let's see, what do we have here? Okay, wait, you've gone off the view. Can you bring it closer? No, not yet. We'll adjust this. We need to switch off some light which is causing reflections. Wrong one. It's too dark now. Yeah, that's good. Okay, so there is a spool of thread, and let's go out because we need to see how she is pulling it. Okay, so let's see, which way does it go when you pull the thread? Which way do you think the spool will roll? Which way will it roll? Do you think it will roll towards us or away from the camera? Okay, to the left or the right for her. So for us, towards the camera, away from the camera. I say it's going to roll towards the camera.
Towards the camera?
Yeah, towards the camera.
Okay.
Oh, it's rolling away from the camera.
Do
Okay.
you think it's going to roll away from the camera?
I think, wait, was I wrong? Should it roll away from the camera? Maybe it should roll away from the camera. Wait, now it's rolling towards the camera. You're playing tricks on me again. Now it's rolling away and towards. Uh-oh. So sometimes it rolls towards the camera, sometimes it rolls away from the camera, and sometimes it just doesn't roll at all, it slides. Now that's strange, isn't it? So try this at home. What are you doing? Are you pulling it? I know what you're doing. You're pulling it at a different angle.
Yeah.
Let's observe how she's pulling it.
So when I'm pulling it horizontally, then it is moving
Away. So it is wrapping around itself. It's wrapping the thread around itself. On the other hand, when you pull it vertically, it unwraps the thread and rolls away. I mean, sort of, it rolls, the thread gets unwrapped, it rolls in one direction to the left maybe, and when you pull it, if you're right-handed and you're pulling it towards the right, it will.
Yeah, it depends on how it is wrapped. So when I'm pulling it horizontally, it is wrapping itself, and when I'm pulling it vertically, it is unwrapped. So if I do it the opposite side, the opposite thing will happen. Yeah. So it is going like this, and it will come like that.
Okay. So let's take a minute and try and think of why this happens. Why does it roll both ways, and at some critical point it doesn't roll at all?
Yes. So the angle, of course, will depend on all the material but yeah, you have to play around and figure out this angle where it does not roll either way. Yeah.
Okay, so why does that happen? Well, I'm not going to give the answer completely, but again, it's always good. It's always good to draw a diagram. So let me try and draw a diagram of what she did. So she had let's say that was the wheel, okay, and over there's a circle on which there was lots of thread that was wound, and if you pull the thread this way, then it was winding up.
Yeah.
So if you pull the thread this way, it turns in that direction. On the other hand, if you pull the thread vertically, if you pulled it this way, it goes that way. And clearly in between this, so if you pull it this way, it rolls in that direction. If you pull it vertically, it rolls in that direction. And clearly in the middle of this, there is some critical angle at which if you pull it at that angle, these two sort of balance out and you are effectively, this is just going to slide along the table. Okay. And again, it's our great friend friction that's going to come into the picture, as well as the size of this roll, it's the thickness of the thread, all these things are going to come in. But the idea is, if you are moving something about this point, there has to be a torque, a pair of forces that acts on it. The other pair, you are providing one of the forces, the other force is friction over here, right? And depending on the ratio of this, you can make it roll either this way or that way. Play with it a little. I could give you the answer, but I think it's nicer when you play with this and figure out how exactly does this move, and maybe you would also get a hint at this, but otherwise this is a rather standard problem we should see. Okay, so maybe can we just check what the situation in Kurukshetra is like? That's the place where it is nearest to annular. So let me just quickly check that camera, because we absolutely do not want to miss the annularity part. So
from here only.
yeah, I think we can check from here. Just don't share screen right now. I'll just check from here. How do I get out of?
No, wait.
Oh, it's not a great one. Is there a better stream? But Hanle is not going to be as. Oh, damn.
There's something else.
Which one is this?
No. There is some tech brat streaming.
The Vigyan Prasar stream from Kurukshetra is the problem is most of the people are blocking the image there, so it's not possible to see very much. Let's see if there's another stream that we can get onto.
This is CGTN.
From where?
Dubai, Karachi.
Okay, so this is good. This is the Aniket's thing. This is the Ayuka one. So I'll just share this for a bit. Okay, so here is a summary from the Ayuka live stream. So you can see on the right side the difference between the view in Rajasthan, where it's almost heading to annularity. In the middle is the view from Hanle, and the southernmost one is from Pune. So we probably still have a few minutes. So before we get into annularity, let's give you another homework problem to work on before we switch to this. So we're going to get Prerona back. and she's going to try and do something different, meaning I think we can get rid of this now, right? We don't need this. Okay, so let's get back there. Let's stop the sharing. So Prerna actually wants to hang a picture.
Yeah. Yes,
Okay.
yes, Arnab's favorite periodic table, and I want to hang this. Okay. So, yeah. So the question is, of course, you can just hang it like this, right?
But you have two pins.
Yeah, I have 2 pins.
Okay, so now basically, if you're doing this at home, you need to either figure out how you can put 2 pins somewhere, or if you don't have 2 pins, maybe you can find a cooperative human being and just ask them to make 2 fingers on which you can hold this. And I see you've stolen my periodic table. Okay, I like periodic tables, fine. Okay, so the idea is to hang a picture with 2 pins. That's easy, yeah?
Yeah, exactly. That's easy, right?
Okay.
But suppose I tell you to hang.
By the way, what happens if I take a pin out?
Exactly. So now if I take a pin out, it still hangs, right?
Yeah.
So that's nothing great. But what if I tell you that I've given you 2 pins? Now hang the picture in such a way that if I take out one pin, it will fall down. The picture will fall down. Is that
Okay, so the idea is,
yeah? So
now remember in this thing, if I take out the green pin,
okay.
okay, let's do this. If I take out the green pin, well, the picture is going to hang a little off center, but it will hang on the red pin. And if I take out the red pin, well, it will hang, it will get out, but it will hang on the green pin.
Yeah.
Now the idea is, can you hang a picture? I don't know, it's only mathematicians who would like to do stuff like this. They want to hang a picture on 2 pins so that if you do any pin, the picture falls down.
Yeah. So now the thing is, suppose.
Okay, let's not worry about why they want to do it,
Yeah.
but how do you do it? How do you hang a picture on 2 pins so that if you remove any pin, the picture falls down?
So let's try one thing. Right? So if I hang it like this,
Okay.
Suppose I hang the picture like this. Okay. Then is it clear that if I take out this pin?
So you've taken both the straps and put it around this.
Yeah.
Now clearly, if you remove the red pin,
then it will fall.
okay. So let's go to the annularity. Okay, you need to be louder. You got a mask on. That's going to be affecting. Okay, let's try and get to annularity right now. It should be almost time. We have a minute to go. So while you think of this, let's try and look at the. I need to share screen. Where's Zoom?
Go to Zoom.
Okay, so we should be heading to annularity in just a few minutes. So I would say let's enjoy this for the next few minutes while you think of how to hang a picture so that if you pull off any of the pins, the picture falls down. Okay, we can actually move this. Okay, so we are seeing feed from somewhere in Rajasthan right now. What's going on? And let's just see, it should take a couple of minutes more. I don't know the exact location and the time for that, but it should be around noon in most places where this would happen. Oops, now we have the picture on the side. I can actually share the audio of this if you want. Same as system thing? No. Audio settings. think we probably have a bit more to go. Are we muted on this or something? What?
While sharing screen, you should get on.
Yeah, but we don't have speakers. We need the speakers. So I don't know.
No, no, that is fine. So you just have to do systems up.
That is Samir, I know him. Let's see. Can we get that sound? Can you guys connect the sound? Maybe let the speaker hear me. Is there sound on the YouTube channel? No, our YouTube channel. Is it automatically taking the sound?
How do you turn the sound?
Turn on automatically. And it's plugged in there. Huh? It is. We can present Kurukshetra. Okay. Oh shit, damn this. Where? No, they are not. Okay, so
Just have it. Select this and you will get the sound.
okay, we have annularity. What happened? Okay. Oh, isn't this beautiful? This is beautiful. This is the annular solar eclipse. It's a pity that we aren't able to watch it live. This is such an amazing spectacle. So I think we will just wait and watch this for a minute or so before we get back. And let's try and see what happens at the edge when it contacts, when the sort of shadow moves out of the disk of the sun. You can see it's no longer centered. It's almost moving out. And watch the edge to see if you can see the Bailey's beads. Like now, you should be able to see the Bailey's beads at the edge. Yes, there it is. There it is. And that's because of the mountains and valleys at the edge of the moon. You see the edge didn't go away, it formed these little dots. These were the Bailey's beads that you can see during an eclipse. No, whoever is that? Please focus, please focus. Well, that's the Vigyan Prasad team in Kurukshetra, so they aren't hearing us, of course. Uh-oh. And I think that is it. We are back to the crescent. We are back to the crescent. Let's see if we can get to any other channel. So there it was. That was the annular solar eclipse. So I hope you enjoyed that little break for the annularity. Let us get back to thinking about are there annular regions in other places now? Yeah, it was only about a minute of annularity this time or less. I can quickly check if someone else somewhere else is showing annularity. shit, I can't even. What a pity. YouTube is forcing me to watch an ad during annularity. And that too, not an ad which you can skip. No, that's done. Okay, I think we are done. I think most places are done. Anyway, I think we saw the Kurukshetra one, which was good. Thankfully, it was sunny there. Okay, these guys have gone off. Okay, let's go back to our. Okay, so let's get back to Prerana, who is going to take us through this really crazy thing of wanting to put a picture so that it falls down when you remove either of the things. Okay, so Prerana, will you show them that what you were saying, that it's possible to move it so that one of them will make it fall?
Yeah. So doing it for one is kind of.
Can you speak loudly?
Yeah, sorry. So yeah, it's a problem here. I want to hang a picture such that if I remove one, something like this does not happen. It should fall off. Okay. What do I mean by that? So if I ask you to do that for one thing, something like this would work. Okay. So here, if I remove this pin, the picture falls. Sorry. Okay. If I remove this, the picture will fall down. That is what I want.
For any pin.
For anything. Okay.
Okay. So I hope you thought about it, and yeah. So what does one do? Clearly, I need to make it such that on one. So I mean, this must go this way, right?
Yeah.
So that if I pull, let's see, if I put it like this, then I need a third pin here. That won't work. What if I put it back on the pin? What if I put it like this?
No, but
No, that won't work either. Wait. So clearly, if I put it this way,
then again.
then that pin won't work.
Yeah.
Okay. I don't know. This is too difficult.
So what is the idea? What did we do here, right? So what we did here was that once we put the string in from clockwise, basically,
Just now.
okay, from top of the pin, we
Again,
to
the
put
white
the
background, I think
string
white strings.
clockwise, and to make it fall when we took this pin out, the other time we put the string.
Do you think we can just do it with the green string?
Yeah.
Because the white string is the audience is telling us the white string is not visible.
Oh.
Let's quickly do it with some green string. How much is this much string enough?
I think so.
That much string is enough? Yeah. Okay, just give us 30 seconds. We will.
Just cut this.
Just give us a minute. We'll make it easier to watch. I agree that the white string was not visible on the whiteboard. This is what happens in lockdown times where everybody develops their experiment at home, and then we come together to try and do it. There you are. And
Can you just try this?
I will try it. Okay. All right. Sorry for that small break, but hopefully you should be able to see it a lot better now. Okay, so there's our picture, which we are hanging, and now the thread is nicely visible. Visible. Okay. So now,
So yeah.
just go through this again and loudly, please.
Right. So what was I saying? So even when we did it for one pin, if we take out one pin, it falls down. What did we do, right? So if you focus on on this pin. Then the first time I put the string clockwise from on top of the pin, right? And the second time when I put it, it was anti-clockwise, right?
So there was a question.
That is why if you remove this, it's like the clockwise and anti-clockwise is cancelling itself out, each other out, and it just falls. Okay, this is falling because of right. So once it was done clockwise, the other time it was anti-clockwise. So if I pull this out, it will fall down, right? So the thing is, we somehow have to put it in such a way that this logic works for both pins. Now, how do we do that? It's simple, right? So this is going clockwise. This, I'll make it go anti-clockwise. Now this I had gone clockwise, so I will make it anti-clockwise. Right? And this one I had gone clockwise, so I will make it, sorry, this I had gone anti-clockwise, so I will make it go clockwise. Right? That is all you need to do. You need to put it in such a way that for both pins, once you go clockwise and the other time you go anti-clockwise. Let's see if it works out. If I take this pin out, then this falls. And let's do it one more time for the other pin. So we go clockwise, anti-clockwise, anti-clockwise, and clockwise. And this time we'll pull this one out. And this will fall. Does that make sense? Should I maybe do it on the board? Or
Yeah,
something?
so maybe you should just
Yeah.
at least sketch out what you
Sketch out
did.
what I did on the board. Yeah.
So we've cleaned out the board for you, and
So what did we have? We had two pins, right? Let's just focus on one pin. If there was only one pin and I told you that do it in such a way that if I pull this one out, the picture will fall. What did we do? We did like this, isn't it? Now if you notice, once the string went clockwise along across the pin, and the second time we did it, it went anti-clockwise. So that if we rub this out, it would clearly just fall. Now the thing is, we want to do this for both sides. How do we do it? It is simple.
you want colored chalk? We have different colored chalk.
So we have to put the same logic for both. So just like on this we did once clockwise, the other time anti-clockwise, we need to do it in such a way that for both pins, you will thread it once clockwise and the other time anti-clockwise. So what did we do? We did clockwise. Actually, we did clockwise, then anti-clockwise. So this was clockwise, this was anti-clockwise. Then because this was clockwise, we need to go anti-clockwise, right? And because this was clockwise, we need to go anti-clockwise now, and we get this.
So where is your picture hanging in this? Show the two ends to your picture.
Oh yeah. Okay. Yeah. Or you don't have to necessarily do like this either. I mean, you can do like this is clockwise. You can do clockwise again. But then you need to undo that. So this is anti-clockwise, and because you've done that clockwise, you need to go anti-clockwise again. So you have that. So I mean, yeah, you can do it multiple ways. The only thing is, for both pins, you need to have once clockwise, the other time anti-clockwise. That's the only thing. so that it cancels each other.
Okay, thanks so much. So here is a mathematical curiosity of hanging a picture on two pins so that if you remove one or the other, anyone you remove, the picture falls down. But anyone in their normal sense, if they put two pins in, the whole idea was that in case one falls, the other holds it. So please don't try this at home with your paintings or something. Please try and put them that they do not fall, even if the pin is the nail or pin that's on is removed. But this is a mathematical curiosity, but this might be useful. So let's get back.
Just one. No, so I just want to give one reference. There are many math channels, okay, which explain stuff very well. So, but this explanation, especially, I have taken from one YouTube channel called Stand Up Math. It's by this mathematician called Matt Parker, and he is a stand-up comedian as well as a mathematician. So it's an amazing thing, and he gives like amazing explanations to math problems. So yeah, please check out this YouTube channel. It has nice explanations.
Okay. So thanks so much. That was a little heavy. We are running a little late, but we will show you one really quick, one more game, a little toy you can make, good for kids. And this is with a straw to blow a string. So let's try with the straws. Here's a straw. There's a ready one. Yeah, there's a ready one, but let's just try and make one. So the end product is going to be like this. It's going to be a straw with a little loop of thread through it. But let me tell you how we make it. So first, just take a smaller straw. So here is a bit of straw, okay? And on one side with a pen or a pencil, where did I leave my pen? Pencil, something sharp. So you need to basically make a hole at an angle. So on this, what I'm going to do is I'm going to make a hole at about a 45-degree angle. Okay, this is not going to work. We have pins. We have, of course, pins. If pins can be used for hanging pictures, they can also be used to make holes in straws. So here I make a hole initially with I'll start the hole off with a pin, but I want a slightly larger hole. So then I will use my pen to make the hole slightly bigger. Okay, so now I have a straw with a hole. And I take some thread. Where is the thread? Where is the little... Yeah, this is good. So let's take some thin thread. Okay. Okay. And I will thread it through this hole and out of the straw. This is going to require some patience, but patience is good. Okay, I just sucked it. So here is it. It's going through this, and I tie a knot at the other end. So I'm just going to tie a simple square knot at the other end, or a reef knot as it's called. Tie a knot. Now these threads, you don't want them to hang, interfere with it going in through the thing. So you need to cut the ends of the knot. Cut the ends off really close. Okay. So there we've tied a knot, and we've got something that goes through the straw. Oops, it came out. We'll have to do this again. Just do this again. Meanwhile, I'll show you the one which we've already made. So you see this one. There is a knot, but the knot has really been. The threads have been cut on the other side, so it's small and can go in. And this hole needs to be nice and big. And you can take this and blow. So let's try it this way. Sometimes it gets stuck in the knot. No. Yeah, that's better. Okay, the knot is getting stuck again. Needs a little practice. Let's try on this one. This is even better. So you can make a loop of thread, continuously rotate through your straw by blowing on it. And with this again, If you're a kid, you will figure out all the games you can play with this. But again, you need you don't want this thing hanging around near your knot. You want it really, because otherwise this will get stuck near the straw. So you want to put it close. Okay, let's try if that works. You can shoot out the thread. And you see the thread remains sort of tight when it's in the air because you're blowing on it. Okay, play with this. You get. So is there, with that I think we will end today's session. It's about 12:20 already. Are there any questions on the YouTube channel or on Facebook? Or are there any experiments you want us to show again? Anything that you really liked, you missed, you want to really see one more time? You can do it one more time. Our volunteers checking if there are any questions, interesting questions on YouTube. There's a question about if there's no friction. Okay, yes, this thing which was rolling. Yeah, if there was no friction at all, it would only slide. You need friction for rolling. It has to have friction. So the answer to that is. There's a question on the eclipse. What is it? The red color. Yes, the red color you saw in the live stream that we showed you. Obviously, any camera or something cannot look at the sun directly. You have to use a filter, and they use different filters. And some of these filters will give an artificial color. They don't transmit all colors equally. It's not the real color of the sun. It's just because of the filter used that gives it a reddish hue that we saw. Okay. Any other interesting questions? Anyone wants to see any experiment again?
Why is friction growing exponentially?
Why is friction growing exponentially? Difficult to give a very hand-waving argument to this, but I had drawn a diagram showing you how the rope was going around the pole, right? If you work out the maths of this, and this is probably available in many standard textbooks, you will find out that it goes exponentially with the amount of coverage in angle over the pole, and there is an exponential term that comes in. Difficult to give a very hand-waving argument without getting into the maths of it. Any other questions? Any experiments to repeat? No? Okay, if not, thank you all for watching us. Do go, you might still be able to catch part of the annular eclipse outside. It's probably partial right now, wherever you are. Hope you could catch it. Stay safe and join us again in 2 weeks for yet another session of Chai and Why. Looking at the way things are going, it's unlikely that this is going to be again a session at the theatre. We may just have to do it live online, in which case you'll follow us on YouTube and Facebook. Thanks a lot. Thanks to Prerna, thanks to Divya for developing these experiments, and thank you all for watching. Thank you. Just go ahead and end.
Oh, yeah.